Yeah, welcome to the BLU meeting, December 18th, 2024. Uh, Tonight's meeting, we're going to have Zachary Legal present the Nix ecosystem, which is part one of NixOS presentation that he's going to be making in December this year and January of next year.
Okay,
Zach,
hello. My name
go
is
ahead.
Zachary Liebel. I'm a hobbyist NixOS user. Um, in my presentation, I'm going to basically cover everything that has to do with Nix, except for NixOS, and NixOS will be in part two. So, are you able to see my screen?
Yep.
There should be, yeah, okay. So the first question is, what is Nix? Nix is several things, but most importantly, it's a Turing-complete language. It's a functional language, similar to, say, Haskell or Lisp or whatever. But Nix is, the language is fairly simple, and it's purely functional. Nix is also a package manager. And to go with the package manager, Nix is one of the largest package repositories in the entire world. When you think of a package manager, typically you'll think of apt, or pacman, or whatever, and you associate that with a distro. Like I use apt on Debian, I use pacman on Arch. The Nix package manager is different because it's not necessarily tied to any specific distro. NixOS is an operating system built specifically around the Nix package manager, but you don't have to use NixOS in order to use the Nix package manager. And all of the tools related to Nix are focused especially on reproducibility. Nix was originally released in 2003, so it's actually quite old. It's even older than Ubuntu, which was first released in 2004. And it was, let's see if I can wrap text. Sorry. I don't know. But anyway, it was initially created by a PhD student as a research project, specifically focused on creating a new paradigm of deploying software. It was created by a guy named Ilko Dolstra. And initially, of course, it was just like an experimental project, but it eventually morphed into becoming a very popular package manager and operating system. Nix, like I said, is a package manager that supports many different, that's not necessarily tied to any distro. As you can guess by the name, Nix, it works on almost all the Unixes. So it works on Linux. My presentation is going to be on Pop OS, where I've installed Nix onto Pop OS. Nix also has incredible support on Mac OS. On various BSDs, Nix has various stages of support, not because there's really anything theoretically stopping Nix from being incompatible, but it's just the developer resources aren't necessarily there for the BSDs. Although Nix ports definitely do exist for NetBSD, FreeBSD, OpenBSD. And if you're not, like I said before, Nixpkgs is a package repository, but that contains mostly Linux software. Theoretically, you could make a package repository filled with Windows packages and actually use the Nix package manager on Windows. So right now, there is a lot of work actually being done on native Nix running on Windows. For example, you could install Notepad++ through Nix. But that's just theoretical as of now. The point of saying this is that Nix is not necessarily tied to any specific distro. It's not tied to any kernel. It's not tied to anything. You can basically run it anywhere. So what are the goals? The goal is to basically make software deployments reproducible and declarative. By reproducible, I mean given the same source code and like binary package inputs and whatever else, it will always produce the same output. So if you're trying to build some software using Nix, you're going to take in the source code and whatever else, and it will a lot of the time produce a like byte for byte identical binary. Although some programming languages that's impossible, but that's kind of the idea. So like I said, Nix is configured with a functional programming language. So the state of the host system, like what your environment variables are or whatever, they do not affect what the language evaluates to. You can manually set it so an environment variable can affect your code, but you have to go out of your way to do that, and that's not considered best practice. So because when you evaluate your code, it doesn't take in any state from the current system, you can have very fine-grained control over what kind of inputs are put into your whatever you build. And portable, like I said, declarative, you declare exactly what you want your software to be, and it's supposed to work exactly the same on each system. So let's actually show an example of that. So is this text big enough to see? Is this too small? It's probably okay.
Looks fine for me.
Yeah, it's okay for me.
So this is an example of the Nix programming language. I have a better example of this. So I'm going to show you an example of what you can do with Nix. I'll explain what I'm doing later on. So this is an example of some Nix code. It looks just like any other programming language. So we have a number of data types. You can see here, string var equals example2. So just like any other programming language, let's say I edit this. I just edited it in the left side in my Emacs, and it updated this diagram that I made. So string var equals example1, just like here. You have strings, you have ints, int var equals 15. Let's say I want to change that to 10 or 19. Change it to 19, and it updates here. You have lists, which can contain any data type. So here I have some integers, 1, 2, 3, 4, and then a string. So we can see here. You have arrays, and arrays are very, very extensively used when you're actually configuring your system. So you can have an array of val1 equals 1, val2 is 2, whatever. Here we have val4, as you can see on the left. Val4 is part of rvar, so it's a nested array. And then in val4 is a variable called bunny, which is equal to this array. So you can have nested arrays inside of other arrays. And this can go on forever and ever and ever. Nix. So of course that's just like maybe JSON or whatever basic simple structured data can do this. That's not anything, we're not really talking about programming at that point. But now you can have functions. So up here, if you want to define a variable for reference by other variables, the most common way is to do a let in block. So I have a function right here called add3. Add3 equals taking parameter 1, taking a parameter called num1, and add 3 to it. So if you see later, number equals add 3, 7. And in my diagram, number is 10. So 3 plus 7 is 10. If I want to change it to, let's say 8, it will update, and this should change to 11. So you can actually have logic in your Nix config, which is very different than most other configuration languages. And here is a Fibonacci sequence implemented in Nix. So here I can see fibnum5 equals fib5. So Fibonacci sequence of 5 is 8. Let's go to 6. Now it's 13. And then, so fibnum 15. So Fibonacci of 15 is 987. So I've implemented a fairly complicated function just in a configuration language. So that's the explanation of the Nix programming language itself. Unfortunately,
Zach, this is
yep,
Jerry. I also noticed that you implement that as a recursive function.
yes. So Nix is purely functional, which means that there's no loops, there's no state. So like if you want to have a loop, you're going to have to basically keep track of the previous example of your state. There's no such thing as loops in Nix. You can only do recursion. So unfortunately, it is pretty difficult to learn at first, even though it's a relatively simple language. Since it's purely functional, that's quite a difficult paradigm for your average person to get into. And in order to do advanced things with Nix, you really do need to understand the language. So because of that, you might commonly hear that Nix has a very steep learning curve, which is true. So yeah, you have to do recursion. Now I will show you the package manager. In this example, I'm not going to use the language, but I'll go into using the language later on. So the package manager itself kind of violates the file hierarchy system. Typically, if you have binaries, you'll put them in like /bin or /user/bin. That's not how it works in NixOS. NixOS has its own brand, or sorry, that's not how it works with Nix. Nix creates its own top-level directory called /nix. So when you download software, it's written into /nix/store. It's not written to /user/bin or anything. Everything that has to do with Nix is located in the /nix directory. Now, when you download some sort of software, it will, of course, have the name of the software, but it will also have a hash of all the inputs that were used to build it. So if you have two different versions of, say, Blender, in your Nix store, let's go to that right now. So as you can see, there's like, I don't know how many, maybe like thousands of different things in here. But let's ls grep blend. I've installed multiple versions of Blender. So as you can see, we have Blender 4.3, 4.3.1, 3 point whatever, blah, 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 blah. We have multiple versions of Blender installed on the same system. So I'm running PopOS, and I installed Blender with my native package manager. So the PopOS version is version 3.0.1. But let's say I don't like version 3.0.1. I want something more modern. I can use Nix-Shell. So I'm pulling this package from the Nixpkgs repository, which is on GitHub. Just by default, if you don't specify a prefix, it will automatically assume that you're trying to pull from GitHub. And I'll try to install Blender. Now Blender, it installed Blender 4.3.1. So now if I run the command, you can ignore Nix-GL. That's just because I like to use a specific OpenGL version. But look at that. It's Blender 4.3.1, and it has this nice house. And then if I exit, and I use the native version of Blender, it's version 3.0.1. Now, let's say, Blender 4.3 is too modern, and Blender 3.0 is too old. I want something in the middle. So all I have to do is specify a different version of Nixpkgs. Now it's Blender 4.1.1. So it's so incredibly easy to download the exact specific version of whatever program you want. And the reason why there were several versions of Blender installed in my Nix store is just because before the presentation I had downloaded them, and now they're cached. So you can see it took like a second to set up my environment to run whatever Blender version I wanted. So that's an example of downloading software using the Nix package manager. Now I'll show you the, so Repology is just a website that chronicles how much software is in each distro. And this is an example of, this is a graph showing the number of packages that a certain repository has, and the number of packages that have been recently updated. So as you can see, you have basically every major distro. You have Ubuntu, you have Arch, you have Fedora, whatever. And then all the way out here, you have the various Nixpkgs. So it's kind of ridiculous just how big Nixpkgs is. People love to say to use Arch because you get access to the AUR, which is an incredible package resource, but that's nothing compared to Nixpkgs. You can see and the reason why Nix has so many packages compared to, let's say, Debian is packaging software for Nix is actually incredibly easy. I remember anecdotally, I've packaged software for Debian before, and it's such a pain. You have tons of different files you have to edit. You might even have to repeat the same information in some files. And it's just really a pain. But with Nixpkgs, I'll show you a package definition in a bit, and it's so easy to set up. And Nix even has its own Nix user repository that's kind of like the AUR. So there's probably even more stuff you can install for NixOS. Yeah, so basically anything you could possibly imagine is in NixOS. So if you want to find a certain package, there's command line tools that you can use, of course, but I like to use the web interface search.nixos.org. That's my favorite one, although there are other web interfaces. So as you can see, there's different channels here. Let's go to the Nixpkgs GitHub. So Nix development takes place on GitHub, and I mean, as you can see, it's quite active. But there's all of these different branches. You have NixOS unstable, which is what I usually pull my packages from. But you have various stable versions. 24.11 is the most modern one. You have 24.05, and you have basically lots of different stable versions. Similar to Debian, where you'll have your unstable SID, and then your stable Bookworm, and your testing Trixie, for example. Similar to that. But unlike with Debian, you can install multiple softwares from different branches at the same time, and it doesn't cause a conflict. So let's say my favorite editor is NVI. In unstable, it's version, or let's go back to Blender because we're familiar with that example. We can see version this is the version, and has all this information. This is maintained by the package maintainers and whatever else. If I don't like version 4.3, I can see, oh, what version is in 24.11? This is the version. What version is in 24.05? It's this version. So basically anything that you can search for is probably going to be in here. So now I'll show you a package definition. There's a package called NVI, which is just like which is a very specific version of VI. And if I'm going to go to the source, this is in that mono repo that I showed you earlier, Nixpkgs. This is all of the package definitions are located in the Nixpkgs mono repo. So this is what it takes to package NVI. You have your various dependencies listed here. You have the name of the package, version, and you just fetch the source from wherever on the internet you want to fetch it from. So in this case, Debian is hosting the source for whatever reason, and it'll download the source, and then it'll checksum it to make sure that it's the correct source. And then you can apply patches, like you can include your patch files with the software, or you can download them from the internet. Here's some patches from Fedora that they've made for NVI. And it'll just download this and automatically patch in the software. You don't have to do anything. All you have to do is just list how to get the patches. And then whatever, this will build it. And this is a description of various things that you'll see. So description, the Berkeley VI editor, and here on search.nixos.org, it says the Berkeley VI editor. So that's all it takes to package something for Nix. It's so simple. And all their build infrastructure is super automated. So that's why they're able to get so many packages. Yeah. And like all I have to do is do Nix-Shell, Nixpkgs, and it'll just download and it'll work. Sorry, VI. And I don't know, it has this flashing thing that I don't really know how to use, but that's NVI. So you can see third Berkeley distribution, whatever. This is the NVI. So, and you can see what binaries it provides by looking right here. So it has EX, VI, view. Those are the three binaries that the software is going to provide when you install it. So if I echo my path, you should see right here, in my path, I have in/nix/store. It has a hash of all the build inputs used to build NVI, and then it has whatever NVI, and it includes the bin directory that's included with the package. And that's where these three programs, X, VI, and View, are coming from. It will automatically add it to my path, so I don't have to do anything. And then I'm going to exit and echo path. And now NVI is not going to be in my path anywhere anymore, but it will be in my cache. So it's super simple to download whatever thing you want. Back to the presentation. And yeah, they release a new stable about every 6 months, but I always just use unstable. So I'll show some cool things that you can do with Nix. So I already showed you Nix-Shell, but there's a little bit more that you can do with Nix-Shell. So remember how before I had that diagram, and I had the Nix languages and that diagram. Actually, it's probably better to look through here. So this is the file that I used. Let's zoom out a little bit. In order to make that diagram that I was showing you before, I need some tools. So on my host system right now, I don't have just installed. I don't have plant UML installed. And I don't have none of them are installed. Plant UML is a tool that I specifically use to generate that diagram that I showed you earlier. So how can I not have them installed on my host system yet generate the diagram? The answer is that I use a Nix-Shell. So if we see in this directory, there's a flake.nix file, there's some other stuff, and there's a flake.lock file. So if we see, actually I'll show you that later. So flake.nix is this file that we're looking at here. So a flake.nix file is basically your point of entry into any Nix project. It'll list your inputs, for example, Nixpkgs. Remember how Nix is stored on GitHub? Well, we're fetching it from GitHub. So this is all those 10,000, 100,000 different packages that we're pulling in, and flake utils. That's not really important. I can explain flake utils later. So here I'm downloading Nixpkgs, and in this let block, packages equals import Nixpkgs and set it to the current architecture of the system. So let's say my laptop is currently x86, is running Linux and x86. So it will automatically detect that, and it'll choose the Linux x86 package from Nixpkgs. So remember, I defined packages right in this line here. So dev shell is this shell environment that contains all these packages. So I'm going to enter the shell. notice that this cow appears. And now, which plant UML. These things that I just didn't have a minute ago, now I have perfectly. And that's because I defined a dev shell which includes these packages in the dev shell. All I had to do was type nixdevelop to enter the shell. And if I exit the shell, which now I don't have these packages anymore. So this, and remember, like I showed you before, you can very, very specifically choose with fine-grained detail the versions of whatever packages you want installed. I could install multiple versions of just in this one program if I wanted to, if I had some reason. And then another thing in the shell is a hook that runs when I start it up. So I use cowsay to say you are in a dev shell. And that's where this thing comes from. So for developers, and I can also set environment variables through this. I can do a lot of other things. But for now, I just installed packages and have this graphic here. This being able to, with fine-grained details, decide what the environment variables are and what versions of packages are installed and whatnot, that is going to be very useful for software developers. Traditionally, you would use maybe Docker. You would install whatever version of software in a Docker container, and then you would share that Docker container with your team of developers. And then they would just go into that container and build their software in the container. But this is another way to do it, where you don't have to run an entire container, so it's not as heavy. All this does is just modify your path, which is going to be super lightweight. So for developers, at least, this is really a great competitor to Docker because it's just so much more lightweight and, in my opinion, easier to use, although that's up to the users to decide. So remember, before I have my inputs, let's say I don't want to open the flake file and I just want to see the inputs. Nixflake info. This will show, it'll look in the current directory for the flake.nix, and it'll show me the current inputs. Here I have Nixpkgs, and here I have flake utils. And then nixflake show, this shows me all the outputs. So, like I said, Linux and macOS have first-class support pretty much on Nix. And because I was using flake utils, I didn't explain what it was, but flake utils is basically just an easy way of setting up software for multiple architectures. That's what flake utils does. So I have my dev shell. I have the default dev shell, which I defined up here, right? It's devshells.default. I have an output for x86 Linux, x86 macOS, ARM Linux, ARM macOS. But if I wanted to make another dev shell, I could do and so I'm defining arrays here. So A equals that, B equals that. Right now they contain nothing, but if I was to run nixflake show, did I save the file? Okay, this is awkward. Oh, I spelled this wrong. Sorry. Now I have A, B, and default. And this is building for every single architecture. And if I wanted A to be, let's say, a different version of plant UML, I could just basically copy all this code and paste it in A, but with a different version of plant UML, and it would just work. Instead of running nix develop like that, I would just do nix develop that, and it would just work. So that's nix develop specifically for developers. Nix bundle, home manager is quite an interesting tool. So if any of you have had the problem of setting up a nice home environment on one system, and then later on having to switch to another system, and having it be kind of difficult to copy over your dot files, Home Manager is there to help. So in my Home Manager config, Home Manager just manages your home directory pretty much and your dot files. So in my .config, .config/home manager, you can see a familiar face, flake.nix and flake.lock. Nixflake show, yeah. So this flake has only one output, home configurations. This is, I don't need it to have more, but I have a ton of inputs, and some of these are, I think, are being fetched from GitHub. Some of them are not. Right now it looks like gibberish, so I'll show you it in Emacs. So here I have tons of different build inputs. I have NixVim, which is NeoVim, but you can use Nix to configure it. I have some other stuff that's specific to my configuration. This is my specific version of OpenGL that I like to use, and a couple other things, including Nixpkgs, where I get all those hundreds of thousands of packages. And so this is my config file. Some of it's commented out. But if you don't want your entire configuration to be in one file, what you can do is import your other files. So here I import home.nix, fastfetch.nix, and nixvim.nix. So if I go to home.nix, this is a completely separate file, but it's part of my config because I split it up so it would be easier to read. So what is it? Here I do some cool things with the Nix language, but you've seen that already. Here in Home Manager, I define some symlinks. So if I want to move around my Emacs config, because I'm using spacemacs, so lsl.emacs.d. You can see emacs.d is a symlink to somewhere in the Nix store. And this is supposed to... And then the place in the Nix store is... Okay. It's kind of quite a long train here, but this .emacs.d is symlinked to a couple of things that ultimately get symlinked to my home directory, to home test.config, and then my Emacs config directory that I set up. And that's defined right here in my Nix code. And I do that with a couple other programs too. So if I just ls, this is my Emacs config, and this is part, I have this in a Git repository along with my .config/home manager, so I can move my entire config around just as one Git repo. Here I set some environment variables. This is not part of my bash RC or anything. This is just part of my Nix config. So echo using home man. Oh, sorry. Yeah, so this is just tells me, am I using Home Manager? 1 if true. And in my config file, I set it right here. So if you have, let's say, ZSH, one system uses ZSH, one system it's gone. But this is a permanent way of installing it. So here, I install Emacs, and I install a couple things. So where is my Emacs installed? Emacs is installed in my Nix profile. So interestingly, this is actually not part of the Nix store. This is part of my home directory. But if you're using Home Manager, it's kind of like just Nix, but for your specific home directory. So if I cd Nix profile, cd, yeah, Nix, you can see all of the packages that I installed, or all of the binaries at least that I installed using Home Manager. So here's my various Emacs things. Here's like a game. Here's a, like, basically tells you information about your system. Here's a YouTube client. All of these random things I just downloaded via Home Manager, or let's say KeyPassXC. The version of KeyPassXC that comes with PopOS is really old, and it doesn't support a feature that I use a lot called tags. But this version does. So I actually have to use the Nix version of KeyPassXC. I can't even use the PopOS version because the PopOS is too old. So even if I reboot the system, even if I do whatever, I'll always have these packages that I installed through Home Manager in my path, and they will just be accessible. Now let's say I want to install a new package, something like lolcat. This is just a fun program. So I don't have lolcat installed. All I have to do is cd Nix, do Home Manager, switch, flake, and so I just edited my config file to add lolcat. That wasn't there before. I'm going to build my system right now. It's going to read my config file, and it's going to basically make a kind of like a fake root directory almost that contains all my binaries, all my whatever, and it's going to symlink them to my if I was not using Home Manager, it would symlink them to the Nix store, but since I am, it symlinks them to Nix profile. And then it's going to switch to that. That probably sounded like gibberish, but anyway, which lolcat. Now it's installed. So if I echo BLU, you can see lolcat is working. Lolcat just takes in text and it makes it a random color. Now, let's say, whatever reason, remember that I can do stuff other than installing packages. let's say I do something that I don't like, or something that even kind of breaks my install, and I don't remember exactly what I changed. First of all, you should be using Git to manage your system. I use Git, and actually it's been quite a while since I've committed, but all of these files are in Git. But let's say for whatever reason it's not possible for you to just undo in your config file what you did before. All you have to do is home manager switch list generations. I forget the exact command. Okay. So this is a list of all of the home manager quote-unquote generations. Every time you rebuild your system, like I just did with home manager switch to install lolcat, it basically rebuilds your entire system from scratch. And it puts a symlink to it to your Nix store, which is in the Nix store is actually where your system is configured, or where your system configuration lives. So every time I generate a new system configuration, it'll create a new generation. Now if I install, let's say, neofetch, and I run that same command again, remember we're on generation 36, and it has a hash of JK whatever. And it'll just install neofetch. I don't think I have neofetch in my cache, so it should download it. Wait. This is about average for the amount of time it takes to download a package. Almost everything that I've showed you before was in the cache, so it ran almost instantly, but neofetch was not, so it just had to download it from the internet. Now I do home manager listed generations. We're on generation 37, and the hash is different. So if I want to go back to generation 36, let's say, with the hash JK, all I have to do is run this command, copy the link to the store, and then run this script. And now I go forward a generation, but look, it's the same hash, JK1X, JK1X. So I have neofetch installed on my host, but this is the NVIDIA, this is the Pop! OS version. I guess that's not a particularly good example, but just believe me in that when we had the hash 050 running, it had the Nix version of neofetch, and then when we switched back to the older one, it went back a generation and it did not have the Nix version of neofetch. And then we still have lolcat. So let's say I don't like lolcat. I'll go back even further to before we installed lolcat. And lolcat is not installed. So that in that way, you can go back as far as you want. You can go so many generations back. There's no limit. Just as long as you haven't done a garbage collection and cleaned up your old generations, which you can do in case they're taking up too much space, you can go back as far as you want. So if you break your system, if you install some package that messes something up, or you set the environment variables wrong or whatnot, you can just undo that with a single command by rolling back to a previous generation. Let's see what else is cool with Nix. Oh yeah, Docker tools. this is something that I do that maybe not a lot of Nix users do, but I'd like to do it this way. It doesn't provide too much of an advantage over regular Docker, but for my use cases, it's pretty nice. So this is a file called, in a little project that I have for packaging a software called YigStack. YigStack is basically a user space version of it doesn't matter. But there's a thing called YigStack, and it's not in Nixpkgs because it's very new and it's very obscure. So I need to package it myself. So in my inputs of this Nixflake, you'll see a couple things. You'll see Nixpkgs, right? The thing that that you basically always are going to import. But you also see Nixpkgs 22.11. So I can import multiple versions of Nixpkgs into the same project, and they won't conflict with each other. And then I also have flake utils. And interestingly, I have a link to the program YigStack. This is just a binary. So if I go to, let's say, sorry, I typed that. I'm going to copy this link, and oh, I don't know why it's not copying, but anyway, this is the program that I have linked to. And that's one of these releases. So I download a binary, and that's what this input is. So an input can be literally anything. It can be a binary, it can be an image, it can be a PNG, it can be whatever you want. Most of the time it's going to be source code, but it doesn't have to be. And then here I define packages and the older version of packages so that we can keep them apart. And packages. So this is another dev shell. Remember, I showed you a dev shell that had just plant UML and watch exec. This is a different dev shell that has a couple of programs, but interestingly, there's a program called proxy chains ng that, for whatever reason, the recent versions of proxy chains ng don't work well on my system. So all I had to do is download the older version, download it from the older branch of Nixpkgs, and this version actually works fine. So if you are trying to set up your system and a newer update breaks your config, you don't have to update every single package. You can update every single package except one, and it will just work. And yeah, that's this dev shell here. But the more interesting thing is Docker. There's another flake output called Docker tools, Nixpkgs. These are the outputs. Remember, there's a set of outputs for every architecture because I'm using Flake utils. It has the dev shell that I just showed you, which has the older version of proxy chains. And it has Docker image and Yigstack. So what is Yigstack? Where is it? So here, before I showed you the package definition for NVI, and I said that compared to other distros, it's relatively simple. Well, this is basically as simple as you can possibly go for a package definition. Packages.yigstack equals call package, which is a function that just makes a package, name equals Yigstack, files equals Yigstack bin, which is one of my Flake inputs that I imported earlier. Executable, just make it executable, and put that binary in /bin/Yigstack. Literally, that's how simple it is to make a package for NixOS. So that's another reason why NixOS has so many hundreds of thousands of packages, because literally just these like 6-7 lines of code are enough to define a package. So nix run /yigstack, and look at that. So I'm in the same folder as this file with packages.yigstack. In order to run the command, all I have to do is just nix run and then the name of my package. It's literally that simple. And then use conf.
Recording is on.
Zachary, can you hear me? Are you trying to talk? Oh, Zachary is muted.
Oh, okay. How was I muted for a while?
Yes.
Oh, really? Oh, oops. Sorry about that. I'm not sure how that happened. But a summary of what I said is that this is a package definition. Before I showed you the package definition for NVI, and